Hey there, and welcome. Today, we're going to pull back the curtain on something you do every single day, probably without a second thought, logging into your computer. It feels so simple, but underneath that login screen is this really elegant and incredibly secure process, kind of like a secret handshake between you and your machine. And today, we're going to learn every single step of that handshake.
So seriously, what is really going on in those few milliseconds? How does your computer go from just a jumble of characters in a box to confidently saying, "Oh yeah, it's you. Welcome back. Here are all your files"? It's definitely not just looking up your password on some simple list. No, it's a whole lot smarter than that. And that's the mystery we're solving today.
Okay, so the first thing we need to get our heads around is that to the operating system, you aren't just a name. You are what's officially known as a security principal. I know it sounds a little formal, maybe a little intimidating, but it's really just the system's way of saying you're an entity that it needs to be able to identify.
And here's the first little surprise. A security principal isn't just you, the person sitting at the keyboard. Your computer itself is a security principal. Even the groups you're a part of, like maybe marketing or administrators, they're all considered security principals too. It's the system's fundamental way of cataloging anything that might need to ask for access to something else.
So a really easy way to think of it is like this. Every single user, every computer, and every group gets issued its very own official digital ID card. This card is the foundation for absolutely everything that follows. But of course, every ID card needs a unique number on it, right?
So if the security principal is your ID card, then that ID card needs a unique, unforgeable number. And in the digital world, that number is called a security identifier, or you'll usually just hear it called a SID.
Now this isn't just some random number. It's an incredibly long and complex value that is mathematically guaranteed to be unique. Not just on your computer, but unique across any computer, anywhere in the world, for all time. When your account gets created, it's assigned an SID, and that SID is yours for the life of that account. In fact, even if you delete the account, that specific SID is retired forever. It is never, ever used again. This quote right here from Microsoft's own documentation really says it all. It's basically a digital fingerprint. You can change your username as many times as you want, go from jsmith to john.smith, but your SID, that never changes. And that is the crucial takeaway here. It's brilliant, really. The system doesn't truly know you by your username. It knows you by this unchangeable, unique number.
Okay, so the system has checked your password, it's confirmed you are who you say you are, and it's looked up your permanent digital fingerprint, your SID. Now what? Well, it doesn't just open the floodgates. First, it hands you something incredibly important. It's called an access token.
Now, this access token is created completely fresh, right from scratch every single time you log in. Think of it like a temporary passport that's only good for your current session. And here's the most important part. It contains your personal SID, but it also contains the SIDs of every single group you're a member of. A great way to think about this is like the key card you get at a hotel, right? It has your identity on it, sure, but it's also been programmed to open your specific room, the gym, maybe the pool. All of those permissions are bundled together onto that one card. Well, your access token is exactly the same. It carries your personal identity plus all the keys for every group you're in. And the process is actually pretty simple, but really powerful. Once you're authenticated, the system gathers up your personal SID and all your group SIDs, bundles them together into this secure access token, and then it attaches a copy of that token to every single program you run. From that moment on, you're basically carrying your credentials with you everywhere you go inside the system.
So you've got your temporary keycard, your access token. Now let's flip the equation around and look at the things you want to access. Every file, every folder, every printer, they're all considered securable objects, and each one has its own bouncer at the door, checking IDs.
In that bouncers list, it's called the Access Control List, or ACL. It is literally a list of SIDs, the same kind of unique fingerprints we just talked about, and what each of those SIDs is allowed to do. For instance, it might say the SID for the marketing group is allowed to read, but the SID for the admin group has full control. So let's stick with our analogy. If your access token is your key card, the ACL is the electronic lock on the door. It has a very specific set of rules about which key cards it's going to accept. And believe it or not, every single file and folder on your computer has one of these lists attached to it.
Now, here's a really crucial distinction that a lot of people mix up. The rules on that ACL are called permissions. They're all about what you can do to a specific object, like read a file or modify a folder. This is totally different from user rights, which are about what you can do on the system as a whole, like shutting down the computer or backing up files. So permissions are on the door of the room, rights are your general superpowers.
All right, all the pieces are finally in place. You're walking around with your access token, which is just loaded with SIDs, and the folder you want to open has its ACL acting like a gatekeeper. Let's see the magic happen. So you double-click a folder. In that instant, whatever program you're using takes your access token, your temporary keycard, and it presents it to the folder's ACL, the electronic lock on the door. This right here is the moment of truth. The operating system now performs a lightning-fast comparison. It looks at every single SID on your token, over on the left, and it checks it against every single rule in the folder's ACL, over on the right. It's just looking for one single match that says, yep, you've got the access you're asking for.
And bingo! The system sees that the SID for Group ABC is in your token. And what do you know? It's also on the folder's approved list with read permission. That's a match. The check passes, the virtual door unlocks, and the folder just snaps open on your screen. And this entire security check? It happens in a fraction of a second, every single time you access anything.
So why do we care about any of this? Well, because this secret handshake is the absolute bedrock of modern computer security. It's what allows administrators to get incredibly specific about who can touch what. And because it's all built around groups, they can manage access for thousands of people at once, instead of having to deal with each person one by one. It's a remarkably elegant, scalable, and seriously time-tested system.
You know, this whole model of principals, SIDs, and tokens has been incredibly successful for decades. But as we move into a world of cloud services, biometrics, and totally new ideas about identity, it really raises a fascinating question. What is this secret handshake going to look like in the next 10 or 20 years? Something to think about. Thanks for joining me.